The journey beyond our solar system begins through the asteroid belt, a captivating but challenging region filled with countless celestial rocks. Yet, navigating through it isn't as tricky as it sounds. Each asteroid is spread out by vast distances, over 5 million kilometers apart. Spacecraft like Pioneer 1, Pioneer 2, and the Voyager probes have successfully traversed this region without incident. One might even linger here to explore, perhaps pausing near asteroid 243 Ida to glimpse its tiny moon, or observing the enigmatic fog that drifts over the vacant crater of the dwarf planet Ceres. This region also offers rare cosmic spectacles. For instance, the Galileo probe once captured a dramatic collision between comet Shoemaker-Levy 9 and Jupiter. Hidden within the asteroid belt is an intriguing mystery, the hypothetical planet Phaeton. Did this elusive world ever exist? And if so, what led to its fate? For centuries, scientists have debated this. Embark with us on a journey through the belt to search for remnants of this lost planet. What might the DNA of these asteroids, their chemical makeup, reveal? Could Phaeton have been destroyed by a second sun, or does it somehow endure as a ghostly zombie planet, concealed in the desolate stretches of our solar system? The story of this mystery dates back to the 16th century, when astronomer Johannes Kepler noticed an unusual gap between Mars and Jupiter. He speculated there might be a planet there, but never pursued it further. In the 18th century, astronomers Titius and Bode revisited the idea, discovering a mathematical sequence that described the distances of planets from the Sun in geometric progression. However, a gap remained within this sequence between Mars and Jupiter, roughly 2.8 astronomical units from the Sun, which aligned with their calculations. Let's explore their findings. The approximate relative orbital distances from Mercury to Saturn are 4, 7, 10, 16, 52, and 100. When subtracting 4 from each, we get 0, 3, 6, 12, 48, and 96. Each result is roughly double the previous value, but there's a gap between 12 and 48, prompting the question, could a planet have once occupied this missing spot, about position 24, situated between Mars and Jupiter? This theory gained further support in 1781 with the discovery of Uranus, which fit precisely within the Titius-Bode sequence. A team of 24 astronomers, known as the Celestial Police Squad, began a dedicated search for the mysterious missing planet. In 1801, Italian astronomer Giuseppe Piazzi discovered Ceres orbiting exactly where this hypothetical planet was expected. Although Ceres turned out to be quite small and was eventually classified as a dwarf planet, many believed it filled the gap between Mars and Jupiter. This idea, however, was short-lived. In 1802, Heinrich Olbers discovered another body, the asteroid Pallas, sharing nearly the same orbit as Ceres. Olbers speculated that Ceres and Pallas were fragments of a once-existing planet. According to celestial mechanics, these fragments would regularly pass through the point of the planet's supposed disintegration. After running calculations, Olbers predicted locations where other fragments might be found. In 1804, the large asteroid Juno was discovered in one of these predicted areas, and in 1807, Olbers himself found Vesta. Over time, astronomers identified an entire asteroid belt in this exact region, reinforcing Olbers' theory and leading the lost planet to be named Phaeton, after the hero in Greek mythology. In the myth, Phaeton persuaded his father to let him steer the sun's chariot, only to lose control, causing devastation as he drew dangerously close to Earth. Zeus stopped the impending disaster by striking Phaeton down, flooding the world to extinguish the flames. In 1927, German historian Franz Kugler studied ancient texts and proposed that the myth might be rooted in an actual celestial event. He suggested that around 1500 BCE, an intensely bright object appeared in the sky, followed by a meteor shower that caused fires and floods across regions in Africa and Asia. While no scientific evidence supports a real event linked to this myth, researchers still debate the possibility that Phaeton's destruction was tied to significant geological changes on Earth. Some even hypothesize that a fragment of Phaeton could have triggered the dinosaur's extinction. Proposed timelines for the planet's demise range widely, from 3.5 billion years to as recently as 12 to 25,000 years ago. There's less debate over what Phaeton may have looked like. Early 20th century estimates suggested it was a small celestial body, perhaps between the size of Mars and the Moon, with a diameter between 3,500 and 6,800 kilometers. Scientists theorize it orbited the Sun at 2.8 astronomical units, composed primarily of metals, carbon, and silicates, with some asteroids hinting at water on the surface, suggesting that Phaeton likely had water as well. It probably lacked a significant atmosphere, as no remnants have been found. Despite this, scientists have speculated that Phaeton could have supported some form of life in its subsurface layers. By 1992, the hypothetical planet was even classified within our Sun's habitable zone, suggesting conditions that might have allowed simple life forms to thrive, with potentially moderate temperatures and liquid water, despite its smaller size and farther orbit from the Sun. A major scientific breakthrough came with the discovery of frozen complex substances within the main asteroid belt. The Hubble Space Telescope identified traces of water ice and complex carbon compounds on Ceres and Vesta and on asteroid Themis, which was independently confirmed by two international teams. This discovery suggests that after Phaeton's destruction, essential building blocks for life may have arrived on Earth through its remnants. Sci-fi enthusiasts and mythology lovers took these findings further, imagining that the hypothetical planet once housed an intelligent civilization that relocated to Earth after its demise. Legends of Atlantis are often woven into these tales, suggesting that Phaeton's inhabitants brought advanced knowledge, possibly explaining historical feats like Egypt's pyramids. Although captivating, such theories remain speculative, with no scientific foundation. Several scientifically supported theories propose different explanations for Phaeton's fate. 7 main hypotheses offer varied scenarios of cosmic catastrophe, each with its own strengths and weaknesses. Many people are quick to place blame on others for their hardships, and similarly, scientists have speculated that Phaeton's destruction might be due to the influences of Jupiter and Mars. These massive planets appeared to play a cosmic game of billiards, with Phaeton as the cue ball. Jupiter's powerful gravitational force tugged Phaeton off course, while Mars's gravity pulled in the opposite direction, tearing Phaeton apart in a chaotic celestial game. 16 million years ago, the planet fractured into countless comets and asteroids. However, astronomers from the Edinburgh Observatory disagree, as their calculations suggest such gravitational interactions would have thrown Jupiter's moons into disarray, requiring over 2 billion years to stabilize. Astrophysicists have observed no evidence of this disturbance. Another theory casts Phaeton as an active participant in this cosmic billiards match. NASA scientists, through simulations, suggest that Phaeton's destruction coincided with a period of heavy bombardment marked by frequent impacts on the Moon, Earth, and Mars. This theory proposes that Phaeton's orbit became unstable due to gravitational pushes from Jupiter and Mars, causing it to stir up the main asteroid belt and set off collisions with other celestial bodies. Over time, Phaeton's orbit stretched dangerously close to the Sun, where it eventually burned up under its intense heat. A more dramatic theory involves another star as the culprit. Some believe there was once a second star in our sky, which eventually exploded in a supernova. This explosion may have engulfed Phaeton and left behind remnants that later formed the asteroid belt. According to this idea, Jupiter was initially this second star, which transitioned into a gas giant after the supernova. Ancient myths from various cultures, like the lost texts from the Alexandrian Library, South African tribal lore, and Mayan chronicles, all mention 2 stars in the sky, with one eventually fading after a massive explosion. One catastrophic scenario involves Mars and Phaeton in a near-fatal approach. The 2 planets drew too close and collided, with Phaeton, the smaller of the 2, shattering from the impact. Mars may have lost its atmosphere and any potential life it might have harbored. However, this theory falls short of explaining why no apparent evidence of such a destructive collision exists on Mars. Another hypothesis suggests that Phaeton's own rotation may have caused its destruction. If the planet spun too quickly, centrifugal forces could have exceeded its structural limits, tearing it apart. Irish astrophysicist Ernst Öpik, however, contests this theory, asserting that such an event would only produce fragments no larger than 25 meters across, or possibly vaporize Phaeton altogether. He suggests that if a rocky planet of this size had exploded, Earth would have experienced deadly radiation and scorching gases that could have annihilated all life. Alternatively, Phaeton may have collided with a satellite or rogue object. In this scenario, Ceres, Pallas, Juno, and Vesta could have been its moons. Phaeton might have had another large satellite near Jupiter that eventually broke free under Jupiter's gravitational influence. This wandering satellite may have orbited independently for millions of years, periodically returning to collide with Phaeton. Eventually, it struck with such force that Phaeton shattered, while the satellite was ejected from the solar system. Another version of this theory involves a rogue planet or a stellar core that strayed into the solar system, altering the orbits of nearby objects before colliding with Phaeton. This impact may have stripped Phaeton's crust, transforming it into scattered asteroids, with the debris eventually reaching Mars, possibly contributing to its loss of water, atmosphere, and any primitive forms of life. Lastly, Phaeton may have been undone by an unforeseen adversary within itself early in its history. Imagine witnessing this on a cosmic journey. Initially, a serene sky with no apparent threat from any planet or asteroid. Yet suddenly, an immense explosion would rip through Phaeton, cloaking it in a nuclear cloud. Its remains would scatter into space, eventually forming the asteroid belt. While this scenario seems unlikely, what could trigger such an explosive reaction inside a planet? Natural forces could provide an answer. Earth offers a clue. Natural nuclear reactors can spontaneously occur, as evidenced by the Oklo uranium deposit in Gabon, where a self-sustaining reaction began around 2 billion years ago, fueled by uranium-235, and continued for hundreds of thousands of years before ceasing. On other planets with higher uranium-235 concentrations, similar natural reactors might reach critical mass, potentially triggering a spontaneous nuclear explosion. Though each theory of Phaeton's demise differs, they share one outcome. Remnants of the planet should remain where it was destroyed. Indeed, we find these in the asteroid belt. But that's not all. Phaeton's core might still exist. Some scientists propose that its core may be nearby, playing a key role in our lives. It could be the moon. Stripped of its crust and much of its mass, this object may have drifted close to Earth, becoming captured by its gravity. Myths from the Maya and African tribes even speak of a fireball appearing in the sky around 12,000 years ago, from which the moon was born. Is Phaeton ruled out? Despite the allure of ancient myths and compelling theories, recent research seems to steer us in another direction. The idea of Phaeton persisted for nearly 2 centuries until the late 20th century, when a fundamental issue emerged. The sheer energy required to destroy an entire planet was staggering, and its source remained unknown. While proponents of the theory sought a solution, by the late 1990s, new studies and refined models of the solar system revealed that the total mass of the asteroid belt is just about 0.05% of Earth's mass, far too little for a planet. Even combined, these asteroids wouldn't form something as large as the Moon. They amount to only 4% of its mass, barely the size of Charon, a small moon of Uranus with a diameter of about 1,200 kilometers. Additionally, recent calculations show that Jupiter's gravity would have prevented a full-fledged planet from forming in the asteroid belt. Most importantly, studies found that the celestial bodies in this region have diverse chemical compositions, suggesting they aren't fragments of a single body. So how do we account for the vast cluster of rocks between Jupiter and Mars? The prevailing theory is that they emerged through the gradual buildup of material from the solar system's protoplanetary disk. This process, known as accretion, involves bodies accumulating mass by gravitationally attracting nearby matter. To understand accretion, let's journey back about 4.6 billion years, when the solar system was in its infancy, consisting only of the Sun and a massive cloud of gas and dust, the protoplanetary disk from which planets would eventually form. In this disk, denser areas gathered more matter through gravity. As these areas grew, they became planetesimals, small building blocks of planets, spanning a few meters to hundreds of kilometers. Some grew large enough to become protoplanets, amassing mass through collisions until they evolved into full-fledged planets. However, not all protoplanets succeeded. Trapped in an unfavorable location between Mars and Jupiter, these developing planets faced the gravitational might of the gas giant. Jupiter pulled some of these protoplanets into its orbit as moons, while others were flung out of the solar system. For most, Jupiter's overwhelming gravity made planetary development impossible, like trying to build a sandcastle in a hurricane's path. Jupiter's disruptive role in the asteroid belt. Jupiter's gravity disrupted the orbits of surrounding celestial bodies, making them unstable and eccentric, which led to intersecting paths and increased the chances of collisions that ultimately shattered them. This influence also accelerated the planetesimals, adding energy and speed, which hindered their ability to accumulate into larger bodies. Thus, the asteroid belt became a kind of graveyard for these thwarted planetesimals, though it remains a dynamic zone filled with asteroids. However, there might be a different twist to this tale. When the asteroid belt initially formed under Jupiter's gravitational influence, the gas giant was closer to the Sun. As it migrated outward, pulling Saturn along, their movement stirred up the solar system, similar to a blender, creating a diverse array of asteroid types, carbonaceous, silicate, and metal-rich. This journey of the asteroid belt remains complex and full of mystery, with much still to be discovered. One intriguing theory suggests that, rather than Phaeton, another planet called Planet 5 might have once resided within the asteroid belt. This concept gained traction after the Apollo missions brought lunar rocks back to Earth, which showed evidence of high-energy impacts from asteroid collisions that were powerful enough to melt them. Radiometric dating revealed that these rocks had cooled around 3.8 to 4 billion years ago, aligning with the late heavy bombardment, a period marked by numerous impacts from comets and asteroids on the Moon. Although cosmic impacts were frequent in the solar system's youth, they suddenly halted and then inexplicably resumed. This strange cycle led scientists to theorize that Planet Phi's journey could explain this pattern. Though no trace of Planet Phi has been found, astronomers imagine it as a bold and influential presence. Likely orbiting between Mars and the main asteroid belt, Planet Phi would have coexisted peacefully until the combined gravitational forces of Mercury, Venus, and Earth nudged it closer to the asteroid belt. There, Planet Phi would have faced orbit-crossing asteroids that bombarded it continuously. Unfazed, Planet Phi may have redirected some comets and asteroids toward the Moon and the inner planets. However, as impacts overwhelmed it, Planet Phi was eventually ejected toward the Sun, where it met a fiery end. Unlike previous theories, this hypothesis doesn't link the asteroid belt's formation to Planet Phi, yet some scientists question the late heavy bombardment theory itself, suggesting that the gas giant's shifting orbits alone could have redirected asteroids. Despite some skepticism, the Planet Phi hypothesis remains a topic of interest. The possibility of other hypothetical planets could further illuminate gaps in our understanding of solar system formation. One such theory posits a fifth gas giant near the Sun long ago. Recent simulations by American researchers indicate that Jupiter likely started farther from the Sun than we observe today. For it to migrate closer, it may have expelled smaller bodies from the system, potentially causing catastrophic disruptions like a collision between Earth and Mars or Venus. If Jupiter had made a sudden jump rather than a gradual shift, it might have even thrown Uranus or Neptune out of orbit. While we don't see evidence of these events, the theory that Jupiter moved inward remains a tantalizing possibility. The fifth gas giant and its journey into the cosmos. If, at the dawn of the solar system, there were not 4 but 5 gas giants, much about our system's formation begins to make sense. During Jupiter's migration, this fifth planet may have been pushed to a remote orbit or even cast out of the solar system altogether. Evidence supporting this idea includes the recent discovery by Japanese and US astronomers of 10 rogue planets drifting in space without a host star. These findings suggest that planetary ejection from star systems is a common event in the cosmos. Many scientists believe the Milky Way holds countless rogue planets, though they're invisible to the naked eye due to their darkness. These 10 gas giants were detected through gravitational microlensing, a phenomenon where a planet passing between a distant star and an observer bends the star's light, briefly magnifying it. Though astronomers wondered if these planets could have formed independently, much like stars from primordial gas clouds, they concluded that gas giants would not likely form this way. If they did, the number detected in each survey would be far fewer. This points to the likelihood that these planets once resided in star systems, but were expelled by the gravitational forces of large neighbors or nearby stars. If this theory holds, the galaxy may host as many wandering planets as it does those orbiting stars, perhaps even including our own elusive fifth gas giant. Theia, another hypothetical planet, didn't drift alone through the cold void, but met a fiery end, leaving behind an irreplaceable legacy for Earth, our moon. The moon's origins remain a mystery, yet one leading theory suggests it was born from a colossal collision between Earth and a Mars-sized protoplanet named Theia. This impact likely occurred during Earth's early formation, when it had achieved about 90% of its current mass. Instead of a direct hit, the collision was glancing, unleashing an energy estimated at 100 million times more than the impact that ended the dinosaurs. The force of this impact caused Earth to spin faster, completing a rotation every 5 hours, with a notable axial tilt. Fragments of Theia and parts of Earth's mantle were ejected into space, eventually coalescing under Earth's gravity to form the Moon. This theory aligns with many aspects of the Moon's structure and the Earth-Moon relationship. Initially, scientists doubted that such a precise glancing blow was possible, but later simulations confirmed it as feasible. Recent research from an American geophysics team suggests Theia formed in the same protoplanetary disk as Earth, not as a rogue object. As they grew, their paths inevitably crossed, leading to Theia's catastrophic collision with Earth. While Earth, being larger and more resilient, survived, Theia shattered, leaving fiery debris that initially formed rings around Earth, similar to Saturn's, which eventually coalesced into the Moon. Tyche, the hypothetical ninth planet. Far beyond the Oort cloud, on the distant edges of the solar system, another potential planet, Tyche, might be influencing the cosmos. Researchers at the University of Louisiana have calculated that a massive planet could exist in this remote region, acting as a cosmic snowball launcher. For years, astronomers speculated that the Sun might have a distant companion, possibly a faint star like a red or brown dwarf, dubbed Nemesis. However, observations have yet to reveal its nature, as it hasn't been spotted directly. The last time this mysterious body passed close to the Sun was around 30 million years ago. Further research suggests this companion might actually be a planet rather than a star, with the name Tyche. Calculations estimate Tyche is at least 1.4 times the size of Jupiter. Its gravitational influence could be responsible for sending approximately 20% of all icy comets towards the inner solar system, with some reaching sizes of up to 2 kilometers in diameter. If Tyche were to hurl one of these massive icy bodies toward Earth, the results could be catastrophic, as a comet of such size could theoretically wipe out life on the planet. Distinct from Tyche, another hypothetical resident of the outer solar system, Planet X is believed to be tranquil, posing no threat to Earth. Estimated to be about 10 times the mass of Earth, Planet X is captivating, with a potential orbit around the Sun lasting 10,000 to 20,000 Earth years. Despite its allure, astronomers haven't directly observed Planet X. Its existence is inferred through mathematical models. Scientists have noticed disturbances in the orbits of distant celestial bodies, suggesting gravitational influence from an unknown object. Some astrophysicists speculate it could be a small black hole, while others attribute the anomaly to Planet X's gravity. Interestingly, Planet X might not be alone. Harvard researchers have proposed that another planet, Nibiru, could also be lurking nearby. Adding to this cosmic mystery, an international astrophysics team has speculated that Phaeton, a planet once thought destroyed in a collision with Jupiter, Mars, or another celestial body, could also be out there. This theory emerged after data from the Pioneer and Voyager missions revealed anomalies in the outer solar system, where the probes deviated from their expected paths due to the gravitational pull of an unidentified object, possibly the core of Phaeton, which may have survived its past collision and been expelled beyond Pluto. Imagine if a new planet joined our solar system. Would it harmonize with the existing planets, perhaps even bringing benefits, or would it trigger cosmic chaos? University of California scientists recently modeled such a scenario. In their simulations, they introduced a super-Earth, a rocky planet larger than Earth but smaller than the gas giants, between Mars and Jupiter. Their choice was inspired by recent discoveries from NASA's Kepler and TESS missions, which revealed that super-Earths are among the most common planet types in the Milky Way, though curiously absent in our solar system. The asteroid belt's location between Mars and Jupiter, spanning 550 million kilometers, could theoretically host a super-Earth. Running 1,000 simulations, researchers experimented with super-Earths of different masses and distances between Mars and Jupiter to predict their effects on the solar system. Starting with a super-Earth twice the size of Earth, they positioned it at 2 or 4 astronomical units from the Sun. Inner planets like Mercury, Venus, Mars, and Earth were most vulnerable. Many simulations showed these planets being ejected from the solar system. The outer planets fared slightly better, with Jupiter and Saturn remaining stable, though Uranus risked disruption due to the chaotic influence on its moons. A more extreme model introduced a super-Earth similar to TOI 2095c, over 7 times the mass of Earth in the asteroid belt. This scenario led to severe disturbances. Jupiter and Saturn's orbits elongated, ejecting the new planet, and eventually Uranus, into space. The inner planets were also affected, with Mars projected to be ejected within a few million years, followed by Earth in some cases, whose orbit would deviate drastically, rendering it potentially uninhabitable. Astronomers liken the solar system to a finely tuned clock, where even small changes can disrupt the delicate balance. Thus, adding a new planet could destabilize the entire system. The absence of a planet between Mars and Jupiter, or at the solar system's edge, likely preserved this gravitational harmony, ultimately protecting Earth and sustaining life. But there may yet be hope for Phaeton, the goal of our cosmic journey. If a planet did form within the asteroid belt, it could remain safe, provided it stayed precisely within 3 astronomical units from the Sun and remained no larger than Mars. Like the ancient Greek legend of steering a careful path, this scenario, though speculative, reminds us of the delicate equilibrium that holds our solar system together. The planets we have studied thus far reside firmly within the domain of scientific theory. Yet, it is essential to acknowledge that new celestial bodies could emerge in our solar system at any moment. Among these potential newcomers are rogue planets, as previously discussed. But why have we not encountered any recent sightings? Notably, there have been no recorded observations of such phenomena in recent years. However, during the 17th to 19th centuries, astronomers documented intriguing accounts of enigmatic planets that appeared and subsequently vanished. For example, numerous sightings reported a celestial object orbiting within Mercury's path, located near the Sun, and it was even captured in photographs. This transient visitor was hypothesized to be a dwarf planet and was designated as Vulcan, only to vanish without a trace shortly thereafter. In 1846, a multitude of astronomers claimed to observe a second moon near Earth, which they named Kleinchen, meaning tiny in German. Like Vulcan, this celestial body also disappeared from view. Many astronomers theorize that these fleeting visitors may have been rogue planets drawn into our solar system by the Sun's gravitational pull. Thus far, these encounters have posed no threat to us. On the contrary, scientists remain eager for the arrival of such a visitor, as it might carry remnants of lost civilizations, offering invaluable material for unique studies and opening up exciting new avenues for cosmic exploration. We are currently about 82 million kilometers away from Earth, and in front of us is the least explored planet in the solar system. Its appearance may remind us of the Moon in some ways, and indeed Mercury shares many similarities with our satellite. However, upon closer inspection, numerous traces of asteroid bombardments become apparent. In this regard, Mercury is no less scarred than the Moon. Its craters have extensive radial systems, like the well-known craters such as Kuiper, Beethoven, and Rembrandt. Each crater tells us about its tumultuous past. If Mercury were not so close to the Sun, we might not have been as motivated to explore it actively. It perfectly fits the category of dwarf planets that revolve around the Sun far beyond Pluto's orbit. Despite its relatively close proximity to Earth, Mercury has left us with a multitude of mysteries that we may never be able to solve. The history of studying this planet began so long ago that even now, it's unknown who and when gave the name Mercury to the planet. It's reasonable to assume that it goes back to ancient times. After all, Mercury, in fact, never went anywhere and was observed by people as a bright and rare object visible during early dawn or just after sunset on certain days. This is precisely because it's situated close to the Sun. Its proximity to the Sun, by the way, hampers telescopic observation, not only from Earth, but also from space. For instance, the Hubble Space Telescope has never been and will never be used for observing Mercury. This is because its design doesn't allow for observations of objects too close to the Sun. Firstly, such observations wouldn't yield meaningful results, and secondly, it could result in equipment damage. Hence, the only viable means of closely observing, studying, and researching Mercury is through sending space probes to it. Of course, it's worth noting that in the latter half of the 20th century, radioastronomical and radar methods were actively employed. They allowed us to understand that Mercury has similarities in terms of its reflectivity index, similar to the Moon. This indicated the presence of an extremely thin atmosphere around the planet, which was later confirmed by spacecraft. However, all of this was not enough. Therefore, spacecraft were developed for the exploration of Mercury. Conducting such a space mission with sending a probe to Mercury was extremely complex. First, the spacecraft needed to decelerate to enter a highly elliptical orbit. Then, as it approached the planet, it had to be given an impulse to enter the planet's orbit. During the flight, the spacecraft would accumulate significant speed, and considering the weak gravitational pull of Mercury, it would require a lot of fuel for 2 maneuvers. In other words, the closer the planet is to the Sun, the more powerful gravitational forces the spacecraft must overcome to change its trajectory and speed. For example, sending a spacecraft to Mars is much easier than to Mercury. Therefore, Mercury was explored by a few spacecraft, which can be counted on the fingers of one hand. The first to approach Mercury was the automatic interplanetary station Mariner 10. At that time, it was a unique mission not only because of the flight to Mercury, but also because it was the first mission to visit 2 planets simultaneously. Mariner 10 used Venus to perform an auxiliary gravity assist maneuver, which is now a standard part of interplanetary flights. Take a look at the images that were taken along the way by Mariner 10. It flew past Mercury 3 times, with the closest approach being at a distance of 320 kilometers, lower than the orbit of the International Space Station, ISS. It was with Mariner 10's help that a map of nearly half of the planet's surface was compiled, confirming Mercury's visual resemblance to the Moon. However, unlike the Moon, more prominent and elongated cliffs were discovered on Mercury. By the way, Mariner 10 became the first spacecraft to transmit color and high-resolution digital images. Based on Mariner's data, scientists were able to determine the day and night temperatures more accurately and practically confirm the absence of a planetary atmosphere on Mercury. Mariner 10 determined that the nighttime temperature on Mercury is around -183 degrees Celsius, while the maximum daytime temperature reaches +187 degrees Celsius. Of course, later, temperatures on Mercury were determined more precisely. Using a magnetometer, Mariner 10 also obtained the first indicators of the planet's extremely weak magnetic field. The next spacecraft to study Mercury was Messenger, which took more than 6 years to make its journey from Earth to Mercury. As I mentioned before, Mercury is a very challenging planet for launching spacecraft, and currently, no spacecraft is capable of reaching it directly. Therefore, Messenger used 6 gravity assist maneuvers. I will probably tell you about these amazing maneuvers in a separate video. It took 6.5 years to reach Mercury's orbit, while a flight to Pluto, which is much farther away, would require more time. The New Horizons mission, on the other hand, took only 3 years more. Among its main and significant achievements are discovery of volatile elements evaporating at moderately high temperatures, detection of water ice in and around polar craters, compilation of a detailed map of Mercury's surface, with images of a significant portion being obtained for the first time, special interest in the Caloris Basin, one of the largest and youngest impact craters in the solar system, determination of the chemical composition of the surface and identification and study of traces of volcanic activity, study of the planet's exosphere and its variations with respect to the time of year and time of day, including the detection of exospheric nova tails caused by interaction with the solar wind. Investigation of Mercury's magnetosphere, confirming the dynamic mechanism of its formation. It was previously believed that the cooling process of Mercury's core had long been completed, and it was incapable of generating a magnetic field. However, MESSENGER discovered a displacement of the magnetic field from the planet's rotational axis. These are just some of the discoveries that MESSENGER brought to us, and we will talk about more of them later. An interesting fact is that due to the influence of the Sun's gravity, the orbit of any potential satellite around Mercury would change quite rapidly. In late 2014, MESSENGER ran out of fuel, making it impossible to correct its orbit. Gradually, it descended closer to the surface of Mercury, and on April 30th, 2015, MESSENGER completed its mission by crashing into the planet's surface. According to specialists who worked with the MESSENGER at the Flight Control Center, that day was both celebratory and sad. It was the last time the team heard from the spacecraft, with which they had worked for over 4 years. Before its demise, MESSENGER was supposed to fly at a height of several kilometers over the Shakespeare impact crater, filled with solidified lava, and then collide with an unnamed ridge. If the crash onto Mercury had not occurred, the spacecraft would have emerged from behind Mercury as it fell on the planet's other side, invisible from Earth's perspective. Of course, the operators listened for signals from space, but as expected, the cosmos remained silent. The spacecraft's trajectory model proved to be accurate, and the gravity of the Sun played its role, ultimately sealing MESSENGER's fate. On October 20, 2018, the launch of a new mission to Mercury took place. It happened 2 years ago. We even made a special issue about the BepiColombo mission. It became the next step in exploring the planet closest to the Sun. To save fuel during the flight, BepiColombo will perform 9 gravitational maneuvers, once around Earth, twice around Venus, and 6 times around Mercury. It's worth noting that on April 10, 2020, the maneuver near Earth was successfully completed, and in October of this year, there is an expected encounter with Venus. Now let's talk about the uniqueness and mysteries of Mercury. Personally, for me, Mercury is a complete enigma. However, perhaps the most impressive factor is its movement. Mercury completes one orbit around the Sun in 88 Earth days. It also takes approximately 58.5 days to complete one rotation on its axis. Therefore, within one Mercury year, the planet manages to make only 1.5 rotations around its axis. Due to this, during perihelion, Mercury presents both sides to the Sun at different times. One Mercury day lasts 2 Mercury years, or 3 rotations around its axis. The time between 2 sunrises and sunsets on Mercury is 176 Earth days. So if you want to witness a sunrise and sunset on Mercury, you'll have to wait for about 176 days. But the wonders of Mercury's days don't end there. When passing through perihelion, the planet moves faster along its orbit than on remote sections. Its orbital speed starts to surpass its rotational speed relative to the Sun in the Mercurian sky. An observer stationed in one of the hot spots on the meridian can see how the Sun rises almost to the zenith, then moves in the opposite direction, and then turns around again, continuing its normal movement. But in other places on the planet, you can observe the Sun behaving differently. It rises, ascends not very high above the horizon, stops, moves in the opposite direction, sets, rises again, crosses the sky, and sets again. After that, it finally sets. Moreover, on Mercury, the Sun appears twice as big as it does on Earth, and the sky remains black both day and night. This is because Mercury has almost no atmosphere and is surrounded only by the so-called exosphere, a space so thin that its neutral atoms never collide. According to observations through Earth's telescopes and during flybys of the planet by the Mariner 10 spacecraft, numerous helium atoms dominate the exosphere, but there are also atoms of hydrogen, oxygen, neon, sodium, and potassium. The atoms that make up the exosphere are knocked off the surface of Mercury by photons, ion particles from the solar wind, and micrometeoroids. The absence of an atmosphere on Mercury means there is no sound, since there is no elastic medium, like air, to transmit sound waves. However, the stars in Mercury's sky move 3 times faster than the Sun. For example, a star appearing on the morning horizon at the same time as the Sun will rise in the west before noon, earlier than the Sun reaches its zenith, and will rise again in the east before the Sun sets. Mercury's characteristics on the sky are intriguing, but the mystery lies in how it was formed. To attempt to answer this question, we need to look at its location when it is closest to the Sun, which is 3 times closer than the distance between the Sun and Earth. However, whether Mercury has always been on this orbit remains unknown. There have been various theories about the formation of Mercury, including the idea that it was once a moon of Venus. However, upon detailed study of Mercury, these theories have been refuted. Measurements taken by the Messenger spacecraft, which orbited Mercury from 2011 to 2015, revealed an unexpectedly high ratio of potassium to thorium on Mercury's surface. This is surprising because potassium is volatile at high temperatures, and on other solid planets in the solar system, its ratio to thorium decreases as they get closer to the Sun. However, on Mercury, the ratio of potassium to thorium is similar to that found on Mars, a significantly colder planet. At the moment, no single model of Mercury's formation can fully explain this anomaly. Therefore, scientists hypothesize that Mercury may have formed much farther from the Sun, roughly in the same region as Mars, and then migrated to its current orbit, possibly due to a collision with a large body. Such a powerful collision could explain why Mercury has an unusually large internal core and a relatively thin outer shell. The core's diameter is about 4,000 kilometers, constituting over 55% of the planet's volume. For comparison, Earth's core has a diameter of approximately 1,200 kilometers. Therefore, it is possible that in the past, Mercury experienced a major collision, resulting in the loss of a significant portion of its outer shell, which would explain this puzzle. There has even been a hypothesis that this collision involved Earth, and the debris from it formed our moon. Another intriguing phenomenon of Mercury is its magnetic field, or rather, how it came to be. Not every planet has a magnetic field among the rocky planets in the solar system. Only Earth and Mercury possess it. Mars also had a magnetic field in the past, but it lost it. Mercury appears too small to have its own magnetic field, and though it is almost 100 times weaker than Earth's, it still exists. Earth's magnetic field is generated by a rapidly rotating liquid iron core at its center. Previously, it was believed that due to Mercury's significantly smaller size, it should have cooled down considerably, so there shouldn't be a liquid core at its center. Therefore, the existence of its magnetic field remained difficult to explain. To test if Mercury's core is partially molten, scientists attempted to observe small tidal deformations on its surface during the planet's orbit around the Sun and interactions with its gravitational pull. A slight bulge on its surface should be observed, and its size would vary depending on the distance from the Sun. According to estimates, the maximum height of this bulge should be about 14 meters, and the BepiColombo mission will be capable of measuring changes in this height over several Mercury years during its operation. Another mystery related to Mercury's magnetic field is that the center of the magnetic moment creating this field is not located at the planet's center, as it is with Earth. Instead, it is shifted toward the northern pole. Hence, we eagerly await the results of the BepiColombo mission to shed light on these fascinating aspects of Mercury. Another interesting aspect of Mercury is its water on the surface and whether it exists at all. The surface temperature is over 400 degrees Celsius, 752 degrees Fahrenheit, making it challenging to expect water or ice to be present. However, what's remarkable is that on the bottoms of many craters on Mercury, the Messenger spacecraft managed to observe faint glimmers resembling reflections of light from the surface of water ice. Nevertheless, Messenger couldn't directly confirm the presence of water since it lacked the necessary instruments. But these instruments will be on board the BepiColombo spacecraft, so it should definitively answer whether there is water on Mercury or not. Moreover, if water is present, BepiColombo will be able to estimate its quantity. In reality, the presence of water ice on a heated planet isn't as absurd as it might seem. The axis of rotation of Mercury is not tilted like Earth's, so the sun's rays hit the polar regions at a very shallow angle, providing less intense heating, especially within craters where sunlight may not reach at all. Therefore, a detailed analysis of the elemental composition of Mercury's surface might shed light on the origin of water ice there. Currently, scientists speculate that Mercury might not have had water initially, and that it was brought there, similar to Earth, mainly by comets. However, this remains just one version and is not 100% plausible. Another hypothesis suggests that asteroids, occasionally falling on Mercury, could be a source of the ice. Due to low temperatures in the crater bottoms, water might have persisted for tens of millions of years. Of course, BepiColombo will not provide a definitive answer to the nature of water ice on Mercury, but it will get us closer to finding an answer.